Okay, so I'm going to look at question 3 then from simple molecular substances this time, and this is asking us to look at iodine, the I2 molecule. And it's asking us to look at the forces between the molecules this time, so not actually looking at the covalent bond this time. So, for example, if we look here, then we're looking at an iodine molecule, which is an I2 substance, covalent bond in the middle, but ultimately an I2 molecule. And when we start as a solid, so we've then got another iodine molecule next door to that one, and we are then going to melt that or do something to that. But ultimately, it's saying, why is this a solid in the first instance, and why is that unusual? The reason being is the force, which is the question in force here, is this one. It's the intermolecular force of attraction which exists between the iodine molecules, and normally that force is quite weak. And what that means is, because that's a weak force of attraction, doesn't need a lot of energy to break it, and so when that occurs, it usually means that simple molecular substances become gaseous, or at the least liquids, quite simply. So to still have iodine as a solid is actually quite rare, because that means that the simple molecular intermolecular force of attraction which is occurring in an iodine molecules, or between iodine molecules, is actually very strong, or surprisingly strong, to make it a solid. So moving then into the second question, then this is then again just a physical property of these, is whether or not iodine can conduct electricity in any state. Now, if this is a situation, there's two requirements for the conduction of electricity. One is the movement of free electrons, delocalized electrons, as in situations such as metallic bonding, or in graphite with carbon, or in the case of an ionic substance, we need to have moving ions. So sodium chloride will conduct when either aqueous or molten. In the situation of iodine, because iodine is a covalent substance, okay, we don't have any of those. We have no free electrons, because the electrons are either in the outer shell of the iodine, so that'll have full outer shell and then a pair of electrons in the bond. There are no free electrons. And obviously, because we've got a molecular substance which is neutral, doesn't have charge, there's no charge within an iodine molecule, then we don't have the movement of ions either, and we'll never have that whether we're in a solid, as we are with iodine at room temperature, or in a gaseous state, because iodine sublimes obviously, then we won't have conduction at any state for iodine.